3.6 is hyperbolic trig functions. Laura? Beautiful. Can you go out in the hall and do that? 3.6 hyperbolic. Just a freaking.
Deep breaths.
I'm sorry.
Whew. All right, here we go. 3.5. Yes, I do skip 3.5. I've never taught 3.5. 3.5 is the linearization of functions. Find the equation of the tangent line. Have we been doing that all year? Yeah, it's really weird they spend a whole section on it then when you should be talking about like that the whole year because there's questions on that the whole year. We've covered that throughout the entire year. There's a Newton's method that is involved in that, but I'm going to cover that when it comes up in the integral function because that's where it's more relevant. Jad, you okay?
No.
You don't look good. What's that?
I'm very sick.
Okay, I'm going to stay away from you today. You don't look well, man. Are you sure you want to stay here?
Well, I can't go home. My mom said I have to go to school.
Well, tell her we all appreciate her making that decision. Don't worry, Hoagie, you got the weekend. All right, so we talk about alternate geometries. All right, here we go. Alternate geometries. Okay, so you studied the boy named Euclid. Even though they may or may not have told you that on the first day of geometry, you studied Euclid's geometry. Euclid is a Greek who wrote down 6 postulates. One of those 6 postulates, for example, is that parallel lines never what? Intersect. All lines are defined, like segments are defined as the shortest distance between 2 points. What mathematicians do is they say, well, that was just his rules. Like, you know, there's no thing that came down and said, well, parallel lines never intersect. That's just his definition of it, his postulate. What if we change that? So as Tim puts his phone away and stops researching this online, we go to, well, what if we change that? So, you know, for example, parallel lines have what kind of angles? Congruent. Like, for example, what kind of angles are congruent? Alternate interior angles, right. So what if we change the definition of parallel lines to any 2 lines that have alternate interior angles congruent? And we change the definition of the line to the connection between any 2 points. So like, you know, a line is this, the shortest distance between 2 points. A line could look like this, just a connection between 2 points. So then you get things like alternate interior angles look like this. Or excuse me, said that wrong. Parallel lines look like this because they are 2 lines connecting 2 points and they have alternate interior angles congruent. Now, you have to remember I told you about philosophy majors, like they talk about the way the world ought to work, not the way the world actually works. This is the same thing. Like they're testing the boundaries of math. One of the things you do as a math major is you look at alternate number systems. Like instead of our base, 10 number system, what about a base 7 number system? What about a base 6 number system? Is there any benefits or disadvantages for that? A base 2 number system is really boring because then you're just binary zeros and ones. But that's where it was invented as a very good computer language. So you may think like this is all pie in the sky, but sometimes they find applications of these things that are really like useful for what we want stuff to do. So you do have to kind of think of this as an alternate geometry. Now I'm going to give you the definition of it, and then we'll find out why the derivative works itself out. So Amelia, give me just a minute. An alternate geometry is we talk about different than Euclid's, because I'll forget what I was going to say. All the geometry you did when you were in geometry was just Euclid. That was that guy. But he's the one that wrote the rules on it. That's just his 6 postulates. And then he had apparently a lot of free time and just decided, well, what are the rules? Like triangles. Oh, it turns out they have 180 degrees on the inside. Why? Because parallel lines, you draw a triangle on the inside, and then the alternate interior angles are congruent to the supplementary angle at the top. But that is just lowercase c, Euclid. It's just one word, but I was going to put a D for some reason instead of C. Okay, so an alternate geometry than Euclid's, and that's the only one you study. You like it, you can take that class in college where you just talk about alternate geometries. It's a class called geometry. What do we do that? Or yes, non-Euclidean geometry is usually the name of the class. So in that, we have a function called sine hyperbolic. This is pronounced sine hyperbolic. Sine hyperbolic. The shortcut is it's called sinh. So if somebody says this, they say the sinh of x, they're talking about the sine hyperbolic. What's that equal to? Well, kind of weird. It's actually defined in terms of e. Remember I told you that really weird things end up being defined by e? Ugh, this is another one of those crazy ones. It's the sine, so it still is a ratio, but the ratio is defined by e to the x minus e to the negative x all over 2. Whenever anybody says sine hyperbolic, they mean e to the x minus e to the negative x all over 2. Tim, do you got like a business deal going on right now? What's going on, brother? Your fingers are flying.
I need to get help with physics. That's not
We'll go get Bluff Daddy involved.
I can help you with physics.
And the universe is still structured, even though it's alternate. Yes. Remember, now I hate to put this that Iranians, I know I'm giving a really simple definition. Do not type a paragraph on this. Because the arcs look like hyperbolics that are made. So in geometry, you learned about how there were regular arcs and then there were hyperbolic arcs. These are hyperbolic arcs. Well, nobody, sadly, the last kids that had me in geometry graduated last year. So apparently I'm the only nerd that talks about this. But Laura, it is not of great concern to this class. We just have to find its derivatives. Okay, so the sine hyperbolic is defined by that. It's pronounced sinh. The cosine hyperbolic is equal to e to the x plus e to the negative x all over 2. And then last one I'll introduce to you, the tangent hyperbolic. Oh, sorry, this is pronounced kosh.
Kosh. Wow. Okay.
So kind of like how it's spelled.
Yeah, it's pronounced kosh, like tosh, mosh, posh, posh, spice. Let's go. Hey, enough. Let's go. The tangent hyperbolic, the last one I'm going to introduce you to, is equal to e to the x minus e to the negative x all over e to the x plus e to the negative x. And you may notice, wait a minute, I've seen these before. Guys, stop talking. You're sitting next to your friends. If you want to convince me not to ever let you do this again, that's the case in point. That is equal to sine hyperbolic, not sine hyperbolic over cosine hyperbolic. Because if you copy out reciprocal, the 2's cancel out. You get the sine on top, the cosine on bottom. Josh.
So where did the 2's come from?
That's just the definition of what it is. It's half of that ratio.
It's just math.
Like, and let's go back. Why is sine the vertical over the horizontal, or the vertical over the radius? Like, remember breaking down the unit circle? Like, there's a vertical, there's a radius. That's just the definition that was given. And you need to think of geometry on that same way. Euclid just defined these terms. There wasn't some magical moment that like the creator of the universe came down and said, this is geometry. He literally made the rules, and then everything you did after that is what he did with those rules. Same thing. This is the definition of sine hyperbolic ratio, the definition of cosine, the definition of tangent. So that's how we define that ratio to exist. There wasn't some, like books that came down and gave us these formulas in it, sadly. My master's in math would have been much easier if it was. Tim or yes, Mackenzie?
So tangent hyperbolic. Yeah, options.
I'm gonna have to look that up. I don't remember actually.
Okay.
No, we just say the whole thing out. I'll look that up real quick. Okay, so here's my question to you. In this alternate geometry, is anything different? No, it is not different in terms of calculus. So here's what I want you to find. I want you to find the derivative of sine h of x. But I don't want you to do it that way. I want you to do it using this. What's the derivative of e to the x minus e to the negative x all over 2? And then find out what that's equal to. So find the derivative with respect to x of this puppy right here. 1 minute on your marks. Get set. Math.
Where is that d to the d over d to the x?
That means find the derivative of that thing with respect to x. Rohit, do you know how that's pronounced?
No.
I haven't actually learned that much about geometry, so I haven't really been doing that much of that.
Oh, really? Okay. I learned something. This is pronounced fan.
Fan?
Fan. That's what MIT says. I'm going to trust them.
Okay.
Yeah, well,
Fan. Like Thanos.
That's right.
So entirely different ways to derive that.
Good enough.
All right. Ideas. Help me through this one. Talk to me. What do we do? What kind of problem is this? Do we just give up and take the 0 on this test? Transfer to business finance, where math is just about counting digits. Dylan, idea. What do we even do with this? Help.
Well, begin by making it so that the divided by 2 is a constant. Just
Okay, bring the one. So bring it out front as a 1/2. Oh, that's a good idea.
and then you derivative of side.
Okay, so that's 1/2. What's the derivative of e to the x? Beautiful. What's the derivative of e to the negative x? Now, ooh, that's a what rule function? Chain. The simplest chain you can get, but that's still a chain rule because inside is not an x, it's a negative x. So what's the derivative of e to the negative x? It is e to the multiplied by the derivative of that, which is -1. Okay, what do I do with that -1? Multiply by that to make that positive, right? So that's e to the x plus e to the negative x, which, wait a minute, if I just distributed that would be e to the x minus, no, e to the x plus e to the negative x all over 2, which is also known as, that's sinh. Cosh. Now, is it negative? No, that's just cosh. Okay, so I realized, yes, okay. Now, I realize 99% of the time out of 100, I teach you to understand everything I'm talking about so you could go teach like your parents how to do this. Okay, in reality, you just got to memorize these. You got to memorize the sine inverse, cosine inverse, tangent. You got to memorize the sine hyperbolic, cosine, tangent hyperbolic. Yes, there's going to be one question on this just so that they check off the box that I talked about this.
Apparently, hyperbolic geometry is very important in crocheting.
And here I was about to chew Amelia out for doing that. Little did she know she was doing hyperbolic geometry, and she could have given the ultimate bazinga ever. Okay, so here's your rules. And just go with it, Amelia. Go with it. Go with it.
We're not yelling at you.
All right, here we go. The derivative of sine hyperbolic is cosine hyperbolic. The derivative of cosine hyperbolic is sine hyperbolic.
Oh, wait.
So yeah, there's no negative. It's just the derivative of sine is cosine, the derivative of cosine is sine, and the last one you really need to know is the derivative of tangent hyperbolic is secant hyperbolic squared x. I made a mistake last period. I forgot about that. Okay, these are the 3 you need to have memorized. So remember I told you to make flashcards. You should really be making flashcards of all this stuff we have to memorize. So, you know, if you're really stuck in a dark alley one day, you can just memorize this. That's all you have to know for that. For the homework tonight, I am going to just show you what these are. The derivative of cosecant hyperbolic is equal to negative cosecant hyperbolic, cotangent hyperbolic, the derivative of secant hyperbolic.
Can you move it back down and slow down?
Yeah, you bet. Yep.
Yes.
Okay. The derivative of secant hyperbolic is equal to, is it negative secant tan, negative secant hyperbolic x. You do not need to have to memorize those, but there's questions on your homework tonight that have this. And this really isn't anything more than I'm giving it to you to once again practice those chain rule problems. And the last one, the derivative of cotangent hyperbolic is equal to negative cosecant hyperbolic squared of x. Now, if they're chain rules, what are you going to have to multiply by? The derivative of what's inside. So like if it was secant hyperbolic of 3x squared, negative secant hyperbolic of 3x squared, tangent hyperbolic of 3x squared multiplied by 6x. Haley.
So you might have already into this, but why is cosine hyperbolic whatever not negative sign?
Let's find the derivative real quick. So let's dark alley problem. So here you go. We define.
Thanks.
She wants to get smarter and you're making fun of her. Haley, one day when you're interviewing him for a job, just be like, remember Hoagie when we were in that calc, you're making fun of me for wanting to know what the derivative of cosine hyperbolic of x was and why it wasn't negative. And you made fun of me. Funny you during this interview. So your first question, how fast?
Go until the end of class.
So you're in that interview and you're like, all right, so why should I hire you? Oh, that's not a very good answer. What's the reason you should get this job? Oh, that answer sucks too. Yeah. Yeah, so just remember this moment, Haley. Remember this moment. Okay, so derivative of cosine hyperbolic. Well, that's the same thing as asking, what's the derivative of e to the x plus e to the negative x all over 2? And I feel like Dylan already took us to the clown show, so we're just going to show it again. d dx, I'm going to take that 1/2 out front. All right, so let's go through then. The 1/2 stays as a constant out front. What's the derivative of e to the x? What's the derivative of e to the negative x? Yeah, -1 times e to the negative x. So that becomes a minus. And what is that defined as? That is the sinh. Now, if there was a look up real quick. If there was a negative there and a positive there, a negative there and a positive there, yes, then it would be negative sinh, but we just get sinh back. It's weird how the derivative in hyperbolic, sine's derivative is cosine, cosine's derivative is sine. So it's weird just for sine and cosine how it returns the original function, not the negative of the original function.
It makes sense if you look at the graphs.
But for the context of this class, this is what you need to know. There will be one problem on the multiple choice that will ask you to do this. Again, at the start of the year, they give us a giant list of things we have to cover, and this just happens to be one of those things. So 1 point for memorizing that. But again, you should be making flashcards as we go. I will give you credit for doing them next semester because that's when you have to do it, but it will benefit you greatly in class. Haley, does that make sense?
Yeah.
Is that freaking cool? Yeah, that's freaking. And look at e to the x comes out of nowhere again. Out of nowhere again. The more you do math, e to the x just appears all over the place when you didn't expect it to. Like,
Awesome.
Yeah. All right, anybody ready to do anything besides work a couple examples so you know what you got to do tonight? Yeah, let's go for some. Easy or hard one first? Hard one, why not? Let's go for a bone-crushing, soul-crushing. Your parents wonder why you're crying and it's still taking you an hour to do this problem. Example number 1. But then you show them this and you're like, Dad, just pronounce that. Just freaking pronounce that. Here's the good news. If they can pronounce it, they can help you. If they can't pronounce it, you've just bazinged them. So let's go for f of x is equal to, let's take a look. How bad should we do? How bad should we do? Yeah. Natural log of x multiplied by the cosine hyperbolic of 3x to the 4th minus x. And you got to find f prime of that there x. On your marks, get set. Okay, yeah, first off, thank you for whoever said that. What rules are you going to use for this one? Product, chain, one more. Natural log, yeah. Well, that's true. You will use the power rule as well, but definitely got to find the derivative of the natural log. Now, is this one messy? Yes, it is. It's got life issues. You're the trauma surgeon. Their legs severed, their arms severed, and you got to save them right now or you don't get to pass your residency. Ready, set, go.
The derivative of the natural log
1 over whatever's inside the natural log times the derivative of what's inside.
So out of all the hyperbolic functions, none of them go in the second quadrant, and only the cosh and the sech go in the fourth one. That's nice.
Well, why don't they go in the second quadrant?
Well, if you have a positive number, you can only get something positive out of that
Okay.
value.
Well, e to the x,
Yeah.
no matter what the value of x, will always be what?
Positive.
Okay. So when is e to the x minus e to the negative x less than 0?
If if x is negative. Yeah, that makes sense.
Because then it becomes e to the positive x.
Yeah.
You look sharp, by the way.
Oh, thank you.
Yeah. You going to debate in this outfit this weekend?
I'm gonna have a suit and a tie.
Gotcha. You look sharp, though, with your haircut.
Thanks.
So, Mohit, one more question. Mohit, why do wealthy nations have an obligation to provide developmental assistance? Why does that obligation exist?
That obligation exists because of morality, simply put. We have the responsibility to help other people retain their right to life.
Hold on, you guys keep working on calculus. I'm talking to him about debate. Don't look at him like you're to stop the calculus. So they have an obligation to give up their citizens' own money to help people who are less fortunate than them?
They have the obligation to stop people.
Hold on, go back. What's your value criterion?
Okay, my value is morality, and my criteria. Yes, my value is morality.
Okay.
And my criterion is the preservation of human life and the standards of such.
Okay.
So now this comes in effect in two ways. First is the most obvious. You are helping the lives of those in the developing countries. You can be saving them from starvation or simply improving the standards of their life. And that is something that is good. That's something we are morally inclined to do. So that is one moral reason why we should do that.
So the moral imperative.
Moral imperative, yes. My second contention is that if we help these countries develop, we end up helping ourselves in the long run. As if we help these countries develop, we increase the global rate of development and the global product. If the global economy increases, everyone benefits, including those in the home countries.
More than what they give up?
More than what they give up? Definitely. How much of the money in a country comes from trade? Some of the most wealthy nations in the world, for example, China, they make so much of their money off of trade. And if we help those developing nations develop, then those nations will be able to demand more, and they will be able to trade more. With more trade,
more than just domestically investing that money in their own domestic production?
You can invest in domestic production. However, once you bring in more people into the labor market, once you bring in more ideas, more resources, developing nations have insane amounts of resources that are currently untapped because they don't have the development to do so. However, if we go and we help them develop, they will be able to contribute to the global economy and global development as a whole, and that benefits everyone. It's an important part of capitalism that people are able to trade with each other, and the people are able to do what they are best at.
Okay.
Developing nations, if we help them develop, they'll be better at doing what they're good at. And that includes providing labor and providing resources.
Okay.
If those nations are able to provide more labor and resources, the entire world is able to produce more product.
Okay.
If the world is able to produce more product, we are naturally able to live at a higher standard of living.
Okay.
And that's something that if we can do that, we are morally obligated to do that.
Okay. Calls off.
Oh yeah.
You're here.
Yeah. Where would I go like from here? Or is that wrong?
I would just, what's the derivative of cosine hyperbolic?
Just a sign.
Sine hyperbolic, right. Sine hyperbolic with that same thing in sine. That was the proof of why the derivative of sine hyperbolic is cosine hyperbolic, why the derivative of cosine. No. You can, but that's ugly. All right, ladies and gentlemen, who would like to come up and do this one? Oh, yes, we're going to play popcorn with this one, which means you come up and do a step or two, and then you call on somebody else to come do a step or two. Now you may say, but I don't know how to do the next step. What, like I can't have fun in math time? Come on, brother. Just not in the first part of class. No, I don't want to do the whole thing. I want you guys to do the whole thing. Now, here's the good news. If you come up here and you do not know what to do, you may ask anybody in the audience who must help you. So, right, Kaltov, would you like to go first? Come on up, brother. So he will now hold on. If Kaltov wants to come up and work the whole problem, like trying to impress the ladies in class, he can come up and work the whole problem. Do it. Or
Wait, am I doing it on?
yeah, of course. If there was some girl that was gone, they, I don't know, you liked or something, and you wanted her to see your amazing work on the internet, and her volleyball team, and her volleyball coach.
Wait, so I just do like one step?
What?
So I do one step.
Or you can do as much as you want, Kaltov.
One step or more.
One step or more, yes. One step.
Okay. So I'll just find
the. All right, Kaltov, let's go, brother. Let's see what we got here.
I'll just find the derivative of the natural log.
How do you do this?
So it's 1 over. This marker sucks. I would like another.
Sausage. Buckets.
Not even close.
No.
What's this for?
Wait, is that my dot to dot?
Yeah.
No, don't do mine.
Okay. Kaltov, go, brother. You've
Okay.
like 2 minutes.
Yeah,
right now.
so you have 1 over x times the derivative of x, so that's just 1. And then, so that just cancels. So you have 1 over the derivative.
Please.
Oh, that's my apologies.
You guys are guessing.
Why did it take a lot of space just to do that?
It does too. You can do 1 over x.
1 over x.
I mean, 1 times anything is just the same
It
thing.
doesn't count.
Okay, I'm sorry that my terminology was incorrect. Thank you for making me a better math student.
I have no idea what's going on.
Found the derivative of that.
Okay, no, but that's not part of the problem. This is a what rule problem?
Oh, it's a price rule
you
problem.
multiply
Yeah.
1 over times.
Yeah, so this is just,
Kaltov gets called.
and then we'll just define the ln of x as h of x. I just separate, it's literally, we already knew this. I took this and I moved it here. Because I can't put f of x again.
Oh,
Yes,
yes,
you
okay.
can't use that to represent 2 things in the same one, right? Okay, but keep going. Kaltov, what is going on here? Go with the product rule.
That's what I'm doing. Give or take. And then, so you have g of x equals the cosh of 3x to the 4th minus x. And then g1 of x equals the sinh.
Okay,
Do you pronounce it as sinh?
Yes.
Yes.
Of 3x to the 4th minus x. All right, I'm done with this.
No.
Right, call somebody else.
You did good, kid. You did
Mo
good.
hit.
He's not. Oh yeah.
He's sitting in a desk.
Sitting in the desk.
Yeah, you did that wrong.
Then just continue.
All right,
Chain rule.
what's up, boys? I'm thinking I didn't hear why I do this on my own normally.
No.
Wait, can you move on? Are you left-handed, Melvin?
No,
Marty, right?
it's flipped. This is my right hand.
Yeah, but Marty, right?
That's how he writes.
I'm not making fun of him. I'm asking him a simple question, Mr. Beckman. If he wants to ask me why I write the way I do, I wouldn't be offended. I would say just because I have tendonitis, and that's how I
I mean, you want me to write like that, or?
I'm taking this away from you guys. This is what I get for trying to have fun.
No.
Okay, yes. There you go. Okay, yes.
Yeah, chain rule. Got to remember that. Okay, that's that. Who needs to do? Who wants to do this? Who doesn't want to do this?
I would do it, but Nick.
Let's do it.
I know. Just rewrite everything.
Just rewrite everything.
Just write it out and don't simplify it.
Write it out and don't. Okay, well that doesn't really make any sense. But okay, so we have.
Here we go.
That's really small. I'm gonna write the bigger.
I'm paying attention to how everyone writes.
This is like the biggest mess I've ever seen in my life.
What is that?
Yes.
We're almost done. There's light at the end of the tunnel.
Okay, so then we do.
Parentheses.
Okay, and then
Keep going. No,
just like let me do my thing and okay. Okay, well that's not really my style, so
Okay, you can say shut up.
that's not really my style either. So
You say be
ah.
Oh no.
We gotta bring it back.
9, 7, X.
Oh, it looks like a kite. Is that what high school's going on?
Okay.
We're just
Done.
talking about it.
It's a done this thing.
Do we have to simplify? Oh, that's right.
Okay. That is also one of the worst things I've ever.
Avery, can you scoot it just a little bit over so we can see the after back equal to? Okay, a couple of you already asked, is this how you have to simplify to? Is there anything you can see that will simplify that will make this pretty?
No.
Not at this point. And again, I know that don't worry, I teach pre-calc 2. None of you had me for pre-calc, but I teach pre-calc 2 where we talk about simplifying, and we will get there just in chapter 4 when we have a reason to simplify. Right now, we're only focused on finding derivatives. That's it. So that, for me, is a full credit, nice final answer.
Woo, sweet.
Okay, now check out questions, but it,
So, I did this with like both sides of the Can you replace that with like e to the both sides minus e to the?
you could, but is there a reason to? No, the only reason I did that was to prove what the derivative was. But if I'm asked to find the derivative of sine hyperbolic, it's cosine hyperbolic. If I'm asked to find the derivative of tangent hyperbolic, it's negative secant hyperbolic squared. But that was just to prove what it was. So remember when she asked, like, why is the derivative that? And I could go back to the e to the x definition and use it to find it. That's just to prove what the derivative is.
Yeah, don't worry too much about the sine hyperbolic and so on. It's like one problem that might be on the test. And beyond that, it's not really used too much unless you go into hyperbolic geometry.
I'm not debating that. I'm just doing my job that I'm supposed to teach.
Yeah.
So I'm teaching this. All right, good news, bad news. Who's going to go first? Next out your homework. If you want to get started on it, you got 15 minutes. If you want to get going on it, you do have a test next Wednesday, which means we do a review on Monday. This test is largely memorization. So you have to have a whole bunch of and things memorized. If you want to know what those things are, you have to have the logarithm derivative memorized. Yes, I can write that.
Yeah.
But they do it with some stuff. If you don't do that, right, my dude, because you're thinking about LD when you never say please. It takes too much time. Okay, what do you have to have memorized? Okay, you have to have the log. You have to have what you have to memorize for your test. Because I'm not gonna lie to you, this test is largely chain rule, implicit, memorizing all the stuff that we learned after that. Chain rule, implicit, memorizing all the stuff we learned after that. Chain rule, implicit, memorizing all the stuff we did after that. So you have to have you have to have memorized the derivative of log. You have to have memorized the derivative of some number to a power. You have to have memorized the derivative of natural log. You have to have memorized the derivative of sine, cosine, tangent, inverse, and you have to have memorized sinh, cosh. Say it again, Laura. Which way?
Left.
You bet. and fan. Okay, so I know first test was all about limits. You have to have those limit properties memorized. Second test is all about finding the derivative, both by the definition and the shortcut, and you have to know how to do that. This test is largely three things: implicit differentiation, solving for implicit differentiation, chain rule, and all of the stuff we covered after that. That largely is just memorizing those derivative definitions. And I told you at the start, you should be making flashcards as we go along. You'll get credit for it next semester when we're done with all the stuff you have to know. I would highly encourage you to make flashcards as we go through this all year long. Do you want? I could. Can you go home and let my dog out real quick? Okay.
Beckman isn't in trouble.
No, I'm not in trouble. I'm just answering questions on the sub. Because teachers quitting mid-year, such a pain in the butt.
Or like a month.
That's mid-year.
Yeah, this guy made it too. Okay, that's what you have.